Yeah. In this session, let's focus on one of the most important aspects in statistics, wherein the focus is more on inferences. Right? In the beginning itself, we discussed that the entire world of statistics is divided into descriptive as well as inferential. So, the hypothesis testing is one of the key areas as a part of the inferential statistics. Because what we do in this entire chapter is first we try to evaluate any statement that has been made about a parameter of a population. So it could be more to do with evaluating the mean of a population, or making some kind of conclusions regarding the variance of a population or a standard deviation of a population, or some kind of comparisons about these population parameters, like comparing the means of two different populations, comparing the variances of two different populations, whether there is equality between the two, or is there any significant difference between the two. All these kind of aspects we evaluate, and based on that we derive our conclusions on the data. That is what we define in the world of hypothesis testing. So the word itself is nothing but hypothesis is some statement that is being made, and we are testing whether that statement needs to be accepted or rejected. Some statement about a parameter of a population, I would like to test whether statistically that statement is significant or insignificant, whether that statement can be accepted or rejected. So that is what is this chapter talking about, right? Whenever we make any of these statements, they are more particular to the entire population of data, but we may not be having the access to the population of the data. So our testing is primarily done based on the sample. So we actually do something on the sample, and based on whatever the result we get, we try to make some conclusion about the entire population. All right. With that as the basic background, let's get started into this chapter of hypothesis testing. So now that we have defined what is hypothesis and what does the testing mean, let's look at the steps involved in the typical hypothesis testing process. Specify the hypothesis to be tested. So some kind of a statement. Okay, let my claim be like this: the average height of an Indian male is 165 centimeters, or the average height of an Indian male is greater than 165 centimeters, or any other statement like the average height of an Indian male is 5 centimeters more than the average height of an Indian female. When I look at statements of this kind, we are calling all of them as hypotheses. So the hypothesis typically could contain any of the parameters, but here in this chapter we would be focusing ourselves to some of those parameters, like the mean, which is the average. We would also deal with some kind of statistical tests relating to the variance or standard deviations, and we would also focus a little bit on the proportions in the data. So that is what we are calling as the specify the hypothesis, whether I want to test the means or variances or standard deviations or proportions or what. Then select the suitable statistical model. What kind of statistical model needs to be used for that? Right? Do I need to go with a discrete distribution or a continuous distribution? So, or any specific probability distribution that I need to look at? And based on that, carry out the design of the experiment or the study, which means collect the data from the sample accordingly. It could be through a secondary source, or it could be a data that you get through an experiment. You conduct the experiment or you collect the data from a secondary resource, but collect the data and calculate what is called as the test statistic. What is the formula that is used to evaluate whether that statement can be rejected or not rejected? Right? For each kind of testing, we will have a different test statistic. For example, if I have to compare the population means of two different populations, then there is one type of test statistic. If I have to compare the variance of a population with a constant value, then there could be another test statistic. So any kind of statistical test I want to perform, depending on the mechanism of the test, there will be a separate test statistic. And based on the test statistic, we will try to find out the probability value which will deal with the probability of that hypothesis being rejected, as well as the probability of that hypothesis being not rejected. That is what can be computed from the probability value. We'll discuss all these things in detail step by step, but as a process, and based on that, finally give the conclusion to the test. So how is it working out? You start off with taking up a claim regarding a parameter, right? Whether you might have made the claim or you might have taken up the claim or a statement made by someone for the testing process. So based on that, you are taking up the appropriate statistical model, collecting the data from the various, collecting the samples of data which will fit in that particular study, creating a test statistic depending on the kind of tests that you want to perform for each of the tests. In this chapter, we are going to deal with at least 10 to 12 different kinds of tests. So for each of the tests, we'll have a separate test statistic which can help us in identifying what is the probability of the hypothesis being rejected or hypothesis being not rejected, and based on that we will typically make our conclusion regarding the test. Once you take up one example, the entire process becomes clear for us. So that is where we'll take the next step in terms of going further. Now, before we go any more deeper in terms of taking up some of the 10 to 12 different types of tests that are available for us, some of the terms which we need to be comfortable with are the null hypothesis. We said initially the first step is state the hypothesis. So as a part of the stating of the hypothesis, we divide that hypothesis, whatever the claim someone has made or you are going to make, we divide it into two parts. One is the null hypothesis, the other one being the alternate. one is the complement to the other. So if the null hypothesis is let's say the average height of an Indian male is equal to 165 centimeters, then the alternate hypothesis always will be the average height of the Indian male is not equal to 165, which means they are completely complementary kind of statements, or probably mutually exclusive kind of statements, right? So that is the difference between the null hypothesis and alternate. I'm making two statements which will be mutually exclusive as well as the exhaustive set. Now, what goes into the null, what goes into the alternate? It's again a very straightforward rule of thumb. Anything that contains an English meaning like equal to or no difference, if I am dealing with only one population, anything dealing with equal to the average height of an Indian male is equal to 165 centimeters. The average, the variance of the heights of the males is equal to something, or the proportion of defects is equal to something. So wherever the meaning, irrespective of the claim made by a person, even if the claim is the height of Indian male is more than 165, even if the statement is like that, when I create a null hypothesis, I will always try to bring in the equality with the hypothesized value. And especially when I am dealing with two different populations, again the meaning is the parameter is equal in both the populations. There is no difference in the average value of the both the populations. Something like that. The equality kind of an English meaning should come up whenever we are dealing with the null hypothesis. So it's a kind of a status quo kind of a scenario, right? And that is what has to go in as a part of the null hypothesis. Probably this world of hypothesis testing has a lot of similarities to the world of judgment or law. Whenever a person is produced in a court of law, the default assumption of the judge is the person is innocent, irrespective of whatever evident crime the person had committed. The initial judgment process is, the initial starting process of the judgment is, assume that this person is innocent. Now, it's up to the lawyers to bring in sufficient evidence, bring in a very strong sufficient evidence to prove that the basic assumption or the basic hypothesis of the judge is wrong and the person is really guilty. If the lawyers are not able to prove with a strong evidence that the person is guilty, he would be assumed that he is innocent. It's not that he is innocent. He is assumed that he is innocent because there is no sufficient evidence to prove that he is guilty. He is assumed that he is innocent, and based on that he would be set free. That's a similar kind of a concept that goes into hypothesis testing. By default, it is assumed that the null hypothesis is containing the status quo with the hypothesized value, which is the equality with the hypothesized value. It's up to the statistical analyst to pick up the data and prove with the strong evidence that there is a lot of deviation from the hypothesized value. There is a significant deviation from the hypothesized value, and it is better to reject the initial premise or the null hypothesis. If that sufficient evidence is not obtained, then we will not reject the null hypothesis, which means we will continue to say that there is no evidence that will bring about that will create a difference of the population parameter from the hypothesized value, right? So the null and the alternate, which are complementary to each other, the null always contains the equality, whereas the alternate does not contain the equality. And just for your convenience, even in the null, I can talk about the statements like this also: greater than or equal to, not just equality in isolation. Even there could be statements like greater than or equal to, or less than or equal to. But there should be equality mandatorily. And the alternate should always be complementary to that. So if the greater than or equal to is there as a part of the null, then alternate will contain only less than. If less than or equal to is as a part of the null, then the alternate will contain greater than. So only one direction. Alternate, in some cases, when I say alternate is containing not equal to, especially when null contains equal to only, the alternate contains not equal to, which means there could be a possibility of less than as well as greater than. Whenever the alternate contains two directions, whenever the alternate hypothesis contains two directions, which means not equal to kind of scenario, we call those kind of tests as two-sided, or sometimes we use two-tailed tests. And whenever the alternate hypothesis contains only one direction, like less than or greater than, because in that case the null hypothesis will contain the complement of it, which is greater than or equal to, or less than or equal to kind of thing. So if the alternate is nothing but the test for rejecting the null. So the test for rejecting the null, if it is in both the directions, we call those kind of tests as two-sided or two-tailed tests. But if that area of rejection, if that direction of rejection is only in one direction, then we call that as one-sided or one-tailed test. And whenever we use the word called test in the context of hypothesis testing, it's a simple rule, it's a simple formula, it's a simple rule which divides your entire data set into two sets. One set will be consistent with the null hypothesis, the other set will not be consistent with the null hypothesis. Now, depending on where your sample data is actually lying as per the rule, is it lying inconsistent with the null, or is it not lying inconsistent with the null? That is what will bring about a conclusion in our statements. Now, there are two other words just for understanding it's better. If at all the hypothesis completely specifies the distribution. What do we mean by completely specifies the distribution? If there is a defined value like equality as a part of our hypothesis, we call it as simple. But if we have a range of values as a part of hypothesis, which means a less than or greater than or less than or equal to, if we have a range of values as a part of hypothesis and not one single defined value, we call those kind of hypothesis as composite hypothesis. So just for understanding the terminology, those two words are required. We need to understand whether something is a simple hypothesis or a composite hypothesis. But more important things as a part of that are the understanding of the words like null hypothesis and alternate hypothesis, and even the one-sided test as well as the two-sided tests. And a few more things. The test statistic. As I have already identified and highlighted, the test statistic is nothing but a formula, right? For testing the means of a population, there is one test statistic. The testing of the variance with a constant value, there is another statistic. For comparing the means of the two different populations, another test statistic. For finding out the means of a Poisson distribution, another test statistic. So any statistical test which we are going to perform, for each test, all you need to know is what is the test statistic corresponding to it. Once you are able to compute the test statistic, automatically you would be able to identify whether the null hypothesis need to be rejected or not to be rejected. So it's something which will be compared, whatever the calculated value based on our sample, it would be compared with some critical value. We'll discuss about what the critical values are, or we have already discussed some of those critical values. Let's say we are talking about a normally distributed data, and we are talking about 95% confidence interval. We said that the critical values are nothing but plus or minus 1.96. Similarly, when we talk about a normally distributed data, and we are talking about 99% level of confidence, again the critical values are plus or minus 2.58, like that. And for other distributions, let's say t distribution or f distribution or chi-square, we have seen earlier that we will be referring to the appropriate statistical tables to obtain the critical values. So whenever we compute one test statistic, we will compare the test statistic with a critical value, and based on that we will be able to make an appropriate decision. The simple logic is, if the test statistic is in the critical region is a word that is typically used for rejection region, which means without lying between plus or minus 1.96, if it lies outside plus or minus 1.96 range, that is what we call as the critical region for 95% confidence level, normally distributed kind of a population. So if we find that the test statistic lies within the critical region, we will reject the test statistic, or we will reject the null hypothesis. Otherwise, we will not reject the null hypothesis. Now, while doing this hypothesis testing, we would be subjected to two types of errors, which are typically called as the type 1 error as well as the type 2 error, sometimes also called as alpha error and beta error. The logic is very simple. See, because we are working on a sample and estimating the population parameters, there is a possibility of an error in the process. So, wherever I am rejecting the null hypothesis, rejecting a null when it should not be rejected, rejecting the equality when actually there is equality between the two. When there is an equality, we are rejecting the case of equality. That is what we call as the type 1 error. Sometimes people also call it as the level of significance. So the probability of a type 1 error is nothing but the chance of rejecting a null hypothesis when it is actually true and it should not be rejected. So that possibility is definitely there, and depending on the significance level that we are setting, we will have that much of probability either to reject the test, reject the null hypothesis, or not reject the null hypothesis. So probably that should be minimized. And similarly, there is a possibility of a type 2 error or a beta error, which is nothing but failing to reject or accept the null hypothesis when it should be rejected. Probably when I go to the legal world, alpha error is nothing but arresting a person or punishing a person when actually he is innocent. When the person is innocent, you are arresting him. That is what is called as a type 1 error. Right? You are punishing the person when actually he should not be punished. That error is very much possible in the judgment process. So what is the chance of making such a kind of error is what is called as a type 1 error. And type 2 is nothing but relieving a person when he is found, when he is guilty. When he is really not innocent, when he has to be punished, he is released. Even that kind of an error is very much possible. That is the probability of type 2 error or a beta error. And we all know from that same world of judgment, I can say the power of a test, the power of a judgment is 1 minus the probability of type 2 error. To what extent a person is punished the moment he is found guilty. So what is the chance that a person, the moment he is found guilty, he is immediately punished? He is not released at all. So that will become the power of the judgment. Or so here when we say the power of a test, it is nothing but the 1 minus the probability of a type 2 error. And logically speaking, both type 1 and type 2 errors have to be reduced drastically. If at all our conclusion regarding a population parameter needs to be very effective from the sample, but in reality it's very difficult to minimize both the errors. Alright, so that aspect of the different kinds of errors that could be involved as a part of the hypothesis testing process, we need to be quite comfortable with. And finally, one more definition which we need to be very comfortable with as a part of this process is the p-value. P-value is nothing but the probability value. And it's the lowest level at which the null hypothesis can be rejected. The lowest possible level of significance, the lowest possible level of significance where the null hypothesis can be rejected. So if the computed value is very, very small, there is a very strong evidence against the null hypothesis. If the p-value is very, very small, there is a very strong evidence against the null hypothesis. So anything less than the significant level, if the p-value is anywhere less than the significant level, let's say I have set the significance level as 5%. Now if the p-value comes much lesser than 5%, I can automatically reject the null hypothesis and I can go with the alternate hypothesis. Otherwise, the chances of going up with the null hypothesis increase and the alternate hypothesis actually decrease. So the lesser the p-value, the more the chance or the more stronger the evidence is to go with the alternate hypothesis. Otherwise, it is more to go with the null hypothesis itself. Right? So once we are comfortable with these various terms, we can actually get started off with the different kinds of statistical tests that can be performed on the data. All right.